record on this computer. Thank you very much. Okay. So we are back to chapter 2. The reason for that is, normally we follow the order. We finish chapter after one another, but because of the setup, normally we have 2 days, like lecture and the way how we set up the quiz and also the assignment, right? So we kind of have to deal with this part, after chapter 3. So, and the topic on its own is kind of standalone, so it's not a big deal in terms of when you learn these materials. So here in chapter 2, these are the learning objectives. So you can notice that objectives 3 and 5, this is about how to determine the mixed components, right? Because when we talked about the cost behavior analysis, we are saying there are variable cost, fixed cost, and mixed cost, right? So mixed costs have 2 components, a variable component and a fixed component. So how can we tease it out, right? Because we only know this data, right? How can we tease out the different component, right? So that's a very good question. How can we know what is the component for the variable cost? What's the component for the fixed cost, right? So we have 2 methods here, high-low versus regression, okay? So today, that's our focus, right? We are going to talk about how to do this analysis. Okay, so like I said, the first approach, let's talk about the high-low method, okay? So I received some questions about high-low, right? I just want to make it very clear that when we refer to high-low, we are not talking about the cost, okay? We are talking about activity level. So when we say high-low, we are saying, let me find the 2 data points, right? Because for each data point, there are 2 coordinates. One is the activity level, the other one is the cost, right? For each data point. If you think about this as the coordinates you learned in high school, right? For each data point, you can do it in the 2-dimension graph. There are 2 dimensions, right? So one dimension is your maybe X, we call it X. So that's your activity level. And then the Y, that would be the cost, okay? So don't mix up this order. Because some students, they make a graph, they use cost as the x-axis and the activity level as the y-axis. So therefore, when you do the regression, your number are not right, okay? So make sure you know, right? When you make that graph, you know that your x-axis is the activity level, and your y-axis, okay, is your cost, okay? So that's very important. So when we talk about the high-low, we are talking about activity level. So basically, you pick the 2 points. That one point with the highest level of activity. The other point is with the lowest activity level. Dan, you have a question?
Sorry, can you just repeat the X and Y axis again? I messed it up in my head.
Okay, so for the X, the horizontal axis, so you use activity level. For the vertical axis, you use cost.
But that's only for the regression, is that correct?
Even for the high-low analysis, yeah. Okay. So that's very important. So don't be confused. Some student wants to pick the highest cost, right? The lowest cost. No, you don't pick those points. You only pick 2 points, okay? You only pick 2 data points, okay? Based on the level of the activity, the highest and the lowest, okay? So when you compare that 2 data point, if you take the difference, okay? If you take the difference, that difference would represent the variable cost between the 2 activity levels, okay? So here's a picture. The 2 girls, they are standing on a bench, okay? These 2 girls, they are in different heights. They are standing on the same bench. Okay, if you think about mixed cost, like the height to the ground, okay, if you measure their height from the ground, right? So they have two components, right? The fixed component, that would be the height of the bench, right? The height of the bench. And the variable component would be the girls' heads, right? The girls' heads. If you measure this height to the ground, and if you take the difference, okay, so you see that the real difference is really the girls' height difference. That's the variable component, right? Because the bench is the same height, okay? Does this make sense? So when you take the difference between the mixed cost at two different levels, the fixed component canceled out. The difference reflected the difference in the variable cost. Okay, so how do we do this high-low method? Two steps. First, you want to figure out what's the variable cost per unit, okay? From the picture, the graph, it's gonna be the slope of the line, okay? So you use the following formula. So the change in total cost at the high versus the low activity level divided by changes in activity. Second step, you want to determine what's the fixed cost, what's the component for the fixed cost. So you can just pick one of the points, right? You don't have to do 2 points. Just pick one point. Could be the highest level, activity level, or the lowest activity level. Just pick one point, okay? And then you would calculate what's the amount of work, because you have just figured out what's the variable cost per unit, right? And if you multiply the highest activity level units, you figured out what's the total variable cost, right? And then the total cost minus the variable cost, that would be your fixed cost, right? So you can either use the highest level or the lowest level. Doesn't matter. You only need one. You are going to get the same result. Okay. So that's the two step. So just give you one example. So in this question, this is the data for the company for 4 months. So you have 4 data points: January, February, March, and April. Can anyone tell me what is the activity for this case?
The kilometers driven.
Activity kilometer driven.
Kilometer driven.
Kilometers driven. Okay. Awesome. Okay, so now I'm asking questions. Please raise your hand, okay? Because I don't want people just speak along, and it's hard for me to make judgment in terms of participation. Okay, so I ask a question, raise your hand. So which month has the highest level of activity, right?
Which
Right?
month? April.
Which month?
April.
April? And what's the level of the activity?
1 lakh kilometers.
Okay, 1,000 kilometers. 100,000 kilometers. Good.
1,000.
Okay. And now, Michaela, what is the lowest level of the activity?
That'd be January with 40,000 kilometers.
Okay, very good. So that's the highest in April and the lowest. Okay. And James, what's the difference in the cost? What's the difference in the cost, James?
33,000.
33. Oops. Yes, that's correct. Okay. So 63 minus 33, 30, 33. And difference, the high 100,000 minus the low 40,000. So 60. Okay. Okay, just give me 1 second. Oops. Okay, so now you can see that the calculation of the variable cost would be 33,000 divided by 60,000. That's the 55 cents per kilometers. That's the cost of the variable, right? Okay, so are we clear? So you pick, first you go with what is the activity. And then you compare the kilometers driven. What is the highest number? That's April. So you are going to use the highest 100,000 and the cost, right? Corresponding cost. So don't go pick up the highest cost. We never pick highest cost. We only pick highest kilometers, okay? Okay, so this is the example. The second step, okay, we are going to calculate the fixed cost, okay? Now let's use the high method. Let's use the highest level of activity, which is 100,000 and $60,000 cost. So what's the total cost? Where should I write? Anyone? What is the Megan?
The total cost is 100,000.
No. What's the cost here? Florence?
63,000.
63,000. Okay. Okay. Karen, how do I calculate? How do I calculate the variable component, variable cost?
Take the 55,000. Oh, sorry, the 100,000 and times it by the 0.55 that we got from the other equation.
Okay. So per unit, 55 cents, and the highest level, 100,000 kilometers. So 55,000. So the difference is 8,000, right? That's my fixed cost. That's the fixed cost. Now let's go with low. Okay, let's go with low. Okay, so who is this? Sorry, I always want to call this name, but I don't know. Tammy? Tammy?
Yes.
What is the total cost, total variable cost for the low, for this data point?
The cost is 30,000 and okay, the variable cost is 40,000. So like we did in the first one, multiply by 0.55 as well.
Okay, so 40,000, that's the
Yeah,
lowest
and
activity level times cost.
And that's 22,000.
22,000. What's the difference? 8,000.
8,000.
8,000.
So you can see that doesn't matter which way you go, right? You still have the same result, right? So when you do calculations, you just pick one. Just pick one. So for teaching purpose, I want to show you both, so you can see clearly by in your own eyes, right? They are the same. Or in the exam, if you have time left, you can just double check, right? Just in case you made some mistakes in the calculation. So if you double check, you still get the same result, right? So you probably have a higher chance of being correct, right? Does anyone have any questions? These are the two steps. Anyone have any question? So if you understand what I'm doing, please sum up. I can see how you guys are doing. Okay. So I guess for the rest of the class, if you don't understand, please let me know. Okay. Okay, so. Okay, so now let's take a look at why we do this, right? We figured out, okay, this equation can be written in two components. In step one, we figured out the variable cost per unit, right? 55 cents. In step two, we figured out the fixed component. And now this cost can be expressed using, this mixed cost can be expressed using this equation, right? And here this is the level of the activity, right? So now we can see that once we figure this out, we can do a little bit of prediction. If the activity level is 45,000 kilometers, okay, then we bring the activity level to here. We can do a calculation. We estimate the maintenance cost would be 32,750, right? So you can see that you use this analysis to find the approximate expression for that relationship. and then you can make some estimation, right? Okay, so now why don't you work on this one? Work on this question, and I want you guys raise hand, okay? So I'm just monitoring whoever raise hand, I will call your name, okay? Once you are done, you are ready to tell me your answer, you can raise your hand. Okay, Irene, what's your answer?
I got 200,750, which is the A.
Okay, thank you. Keep going, keep going. Okay, for other students, you keep going. I haven't, Mario?
Yeah, I got C, 106,250.
Okay, keep going. Everyone can participate. Thomas?
I got C too.
Okay. Long?
I got C too.
Okay. James?
I got A.
Okay. Rag?
I got C.
C. Okay. Maddie?
I got C.
Patricia?
I got C.
Kate? Kate Wong?
I got C too.
Okay. Dan?
Yeah, I got C.
Okay. Okay, so the answer is A. Okay, the answer is A. Yeah, thank you, Kate. A is correct. Okay. So if you get C, I don't know how you get C. 106.
I think they only did the normal equation without like inputting the 4,250. That's why they got.
Oh, I see. So this one, did you get this equation? This is my equation. Y equals 25x plus 94,500. So then how did you get C? Like, if you pick the D, I would understand. Maybe you think you just figured out what's the fixed cost, okay? So you follow the two-step, okay? So this is activity level. The highest is 5,000, and the cost is this number, 219,500. The lowest is 3,000. The cost is 169,500. And so basically the top row and the bottom row, they are corresponds to the lowest and highest level. The difference between the cost 21,9, 16,9, so that will be 50,000. That's the difference in the cost. The difference in activity is 5 minus 3, 2,000. So 50,000 divided by 2,000, that will be $25 per unit. So that's why I have 25 here. And then I can just use anyone, like to figure out what's my fixed component. I can just use, let's say, the lowest, right? The lowest, so we are using 3,000. Okay, so 25 times 3,000, 75,000. Okay, so 16,9,500 minus 75,000. So that's 94,500. So that's my fixed component. And they are asking your prediction. What would the total cost be if the activity level is 4,250? So then you use 4,250 times 25 plus 94,500. So that equals, A, right? So I don't know if this is like the reason why so many students pick this C. I don't know why this is from the social psychology is about compliance, okay? So basically, other people's answer will affect you, right? If you hear so many people are saying C, 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 and then you just shout out C, right? The compliance theory, right? Even though you probably think it's A, but you feel that, oh, so many students are calling C. Maybe C is right. Oh, maybe you didn't even work on it, right? You just want to get a free participation mark, right? I don't know. Anyways, so Nima?
Oh, I was just gonna say how they got C is they multiply 25 times the 4,250, and then they forgot to add the 94,500.
Oh, okay.
Then
So
you'll get
that's-
C.
Oh, that's the difference. Okay, so this is a variable component, right? This is only the variable component. Make sure you have to add this, right? Okay. Anybody have any question here? Okay. Yeah. Should I move on? Can I have your permission to move on?
Yes, yeah.
Yeah, okay. Okay, now let's talk about the regression analysis. Okay, regression analysis. So you may wonder, right? You may wonder yourself, in this example, right? There are 4 months, right? Like January, February, March, and April. And in your calculation, right, you only picked April and January. You didn't use March and February data at all, right? The reason for that is in the high school you learned, right? How many points do you need to make a line? How many points do you need to make a line? 2, right? 2 points, right? You only need 2 points to make a line, right? So that's why we are talking about linear relationship. You only need a high point and a low point. Connecting the 2 points, you make a line, right? But then you basically ignored March and February, right? Okay, so that's one of the limitations of this high-low method, right? So now to deal with it, we are having a different analysis called a regression analysis. Okay, I'm not sure how many of you have learned the stats, right? You probably have to learn one of the stats course, maybe 1770. I don't remember. So basically, under this analysis, you are going to use all the points. Okay, you don't waste any points. Okay, and the benefit is that your estimation will be more accurate, right? Based on all the points, right? Okay, think about it now. How many students we have in class? Just give me, I want to take a look. Sorry. How many students we have in class? Just give me 1 second. We have 40 students in the class, right? Okay. So if I only take 2 students, okay, I'm going to go with guys. Okay, so let me see. Brad, how old are you? No offensive, I won't call lady's name. Brad is not here. Dan, how old are you? See, I'm asking the wrong question, right? That's fine. So basically the idea is if I ask 2 students, right? So then I would say, guess what? I take your average of your age. So I would say, guess what? The average age of this class is, let's say one student tell me 40, the other student tell me 20, and the average would be 30, right? So I only take 2 students, 2 points, and I tell you that, guess what? My class, I have 40 students in my class. Guess what? You know, based on the 2 students' information, okay, one is 20, the other is 40, the average is 30. So, right? So obviously, you know, this is not a very good approach, right? Because I have 40 students. If I only use 2, my estimation is not accurate, right? So what should I do? I should use all the data, right? So I'm going to include everyone. okay? And then I will take the average of the age of everyone, then it's gonna be the average of class, right? So that's exactly the same point here. I apologize for my example for putting some guys on the spot, okay? I can tell you that I'm 40 years old, okay? I was born in 1981. Maybe I'm worried, maybe I look older, okay? But yeah, I'm 40 years old, okay? So how are we gonna deal with this? Okay, somebody, oh, you look younger. Oh, thank you. Thank you very much. Okay, so I will remember that, never ask that question again. Even for guys, right? Maybe the guys is also, they also don't like people asking them age, okay?
Professor.
Yeah.
I could tell you my age if you want. It doesn't hurt my feelings.
Okay, that's okay.
Yeah, exactly. It's a good example. I liked it.
Yeah, I was like,
thank
I
you.
thought it was a fun example.
Okay,
Call the
good.
girls next time. We'll tell you our age.
Okay, thank you. Yeah. So I don't feel bad because I try different things, right? I know over the time I know some works, others doesn't work. I'm learning my lessons just like you guys, right? If you did something wrong in your quiz, so you learn lesson. Okay.
You could also ask us like if we watched like a movie, like I don't know. No, that's too different. Never mind. Don't worry about it. That was wrong.
Okay. Yeah. So that's the good thing, right? You can practice that on your own. Sometimes try to give yourself some examples, right? That probably help you to learn. So here, right, I have 12 months, right? In this example, right? I have 12 months. Okay, so just give me a second. Okay, pretend that you haven't seen anything, okay? So what is the activity in this case? So raise your hand, please. If you haven't participated, raise your hand. Rachel?
It's driving.
Kilometers driving. Okay, good. Isabella, what is the highest activity level?
65.
65. That's the December, right? Okay, and Kate, what is the lowest activity level?
It's July.
July 15, right? So remember, right? If you go with high-low method, these are the two data points you're going to use, right? Okay. So then if you follow that approach to do the calculation, okay. So basically, you take the difference of the cost, 24,000, and the difference in the activity level, 50,000. You get variable cost per unit, 48 per kilometer. And the fixed point, fixed cost, okay? So you just use one activity level, the lowest, 15,000, times per unit, 48, right? Cents. And so you figured out the total variable cost is 7,200, and your fixed cost would be the total, the lowest level, minus 72, 31,800, right? 31,800. Okay, so now you figured out this would be your linear equation. Okay, y equals 0.48x plus 31,800, right? Based on high-low method. Okay. However, look at this. This is the regression. Okay, this is a regression method. Okay, you can see that my points, these points are evenly distributed around this line. Okay, so this line is the fit. So basically, you can draw like countless number of lines, right? You can draw whatever lines you want, right, to approximate this linear trend, right? But the idea is there's only one line will give you the best fit. Okay, what do we mean by the fit? The fit means if you measure from the dot, from the actual data, the dot, and the distance to the vertical distance to the line, okay, and you square it. You take the square and you sum all these data points, then the total number would be the smallest, okay? So basically, if you do for every data, you draw a line, you measure the vertical distance of each point, and then you square that distance, and you add over all the points, you get a sum number. So whenever you achieve a line that give you the lowest, smallest sum, right? So that's the best fit, okay? That's the best fit. So this is from the statistic perspective, okay? The good thing is that nowadays we have a computer, right? So using computer, this was very complicated calculation. Now it's very easy, okay? I remember when I was in high school, when we do physics experiment, right? You have to measure velocity, time, right? You figured out the linear slope, that's your acceleration. Or if you do like a distance or time, you figured out that's your velocity, right? You remember that? Probably not, right? So you finished high school a long time ago. So here, right? When I was doing the experiment, we have to manually, right, using that graded, the grid line paper, manually measure the point. And then we try to have an estimation, right? We just run across to draw a line saying, oh, this is the best fit, right? And then you figured out, oh, what's my intercept, right? And what's the slope? You measure the angle, the tangent of the angle would be the slope, right? But nowadays, everything is so easy, right? You just collect the data, you use Excel, right? And I posted that data, the video to show you the how to get this linear equation, how to add this line, right? It's pretty straightforward, right? Just a couple clicks, right? So you can see here, now, when I use all the point, based on all the point, and I'm able to, get the computer's help to produce this best fitting line, okay? This is the best fitting line, linear line. So the result is my slope, the variable per unit is 18.5, and my variable is 0.81, my fixed is 18.5, okay? Can anyone tell me, okay, what's the high-low method line should look like? So this is the regression analysis. So can anyone tell me what's the line, okay? The high-low method, right? What is that line should look like? Megan?
Would it only have 2 points on it then?
Yeah, so so can you tell me which 2 points? Connecting which 2 points?
The highest and lowest points?
Yeah, okay, good. So the highest means 65, right? Here, and the lowest means 15 here, right? So high-low method give me this line. Do you see it? Do you understand that? So the high-low method will give me this line because this point corresponds to the lowest activity, 15, and this point corresponds to the highest activity level, okay? So when you use the high-low method, these are the 2 points you're going to use, and you connecting them, that's the line you are looking for, right? So this one is this, 48, 31.8, right? We did a calculation. You see, it's quite a big difference, right? Which one is more accurate? I'm looking for somebody who haven't participated yet. You guys all participated already. So I'm looking for a person. Ruben?
Regression line.
Regression line.
Regression line, right? This line is a better fit, right? Because you can see, right? You can see that all the points are evenly distributed around the blue line, right? And they are quite close, right, to the line. But if you use the red line, you can see that, oh, these dots are much further from the red line, okay? Limitation, what's the limitation of regression analysis? So we know high-low has limitations. They only use 2 data points. So you basically did not use all the other points, right? What's the limitation of regression analysis? So basically, first of all, the assumption is linear, right? Because we know that, in the nature, when we, describe relationships, sometimes it doesn't have to be linear, right? Think about in the physics, right? You throw an object, right? You throw object into the air. It's a projectile, right? Projectile. It's not a linear, right? So, but whenever you are using regression analysis, you assume that a relationship in nature is linear, okay? So if the assumption validates, then your result will be misleading, right? Second, outliers. That's interesting, Megan. I was just looking at you. You have the similar headset. Did you see here the happy outlier? And also,
Me and the outlier have good taste.
and also, I cannot see your name. The other students, sorry, I cannot see your name. Okay, so if you do not consider this outlier, right? So basically, you can just run a line smoothly across all these set fits, right? Okay. But when you consider this outlier, your slope will have to be like leaning towards to this outlier, right? Give him some weights. So then your slope will be steeper, right? You have to run a line like this, okay? Here. Okay, so if you have outliers, basically your result will be screwed, okay? So think about if we are in this class, you guys all good students, right? You guys all score like 90% in the class. And I'm an outlier. I scored like 10%, right? So without me, the average of the class would be 90%, right? But because of me, I'm an outlier, only 10%. So I will drag down the average, right? You see the point? Why outliers will affect your estimation, okay? Think about the examples I gave about age, right? Similar idea, right? Okay, Isabella?
But wouldn't the line still be more accurate if you use the regression, even though there is outliers?
Yeah, it will be.
So like in the example of like class, like let's say you're like the highest and someone's like 16, I don't know.
Yeah.
But like, wouldn't the line be still better and more accurate using regression by using everybody, even if the high low? Does that make sense?
Yeah, if you have considering that, yeah. So you are most likely have a better result using regression, okay? But considering, suppose like if we don't have this outlier, my result will be more accurate, right? When you have an outlier, so sometimes you are thinking, well, is this relationship, is this trend or everybody else, this trend reflect the true nature, right? All, this outlier has to be considered, right? So what would be a good example? Just let me think about this. Okay, so suppose that here is a training program, okay? The activity level, the horizontal axis would be the amount of training hours, okay? And the vertical analysis would be, the intelligence increased, okay? So you can see that most people, as the training hours going up, right? Most people's intelligence will be going up, right? Right? You can see the linear trend, right? But the problem is here, we have a super genius. This is Albert Einstein, right? So he does not need a lot of training hours. He's already super smart, right? So then when you are doing a study, thinking about, does training hours matter, right? So then you think, oh, doesn't matter because look at this guy. He does not need too much training hours. He's already super genius, smart, right? So if you consider the outlier, it will tell you that, guess what? Maybe training hours doesn't help, right? But if you don't look at this super genius, you look at the other general population, as the time going, the more training hours, right? Then the intelligence going up, right? The intelligence going up, right? So then you can't make that kind of claim about the relationship, right? So the outliers, they are outliers, right? But including him here is going to affect your result, right? Because remember, when you run the regression analysis, the computer will calculate, right? Do a calculation. Having this data point will definitely screw your result. Yeah. So sometimes researchers may want to get rid of these outliers when they perform research. But people, it's controversial, right? So if this person is a part of your population, you should not remove them from your research. So, you know, but you get the point, right? When you include this outlier, your result will be changed substantially. Yeah. Nima?
Yeah, I have a good question. Concerning outliers, for example, in a business world, if you had like 1 month where you made, for example, $1 million, but on average it's usually like 250, like 250, by removing the outliers, wouldn't that give you more accurate, I don't know, data for you to look at, for example, for your variable unit?
Yeah, sometimes it's really about your research question, right? So when you're talking about employees' salary, you know, it's some kind of function, right? You better define your employee, right? The CEO, like if you think about CEO, they are employees, right? They are the you know, probably the most well-paid employee, right? They are working for the shareholders, right? They are not the boss. So they are making like 200 more times than regular employees, right? So in that situation, they would be outlier, right? So really, you have to define your research question clearly, right? You know, what do you mean by your employees, right? So if you just want to study ordinary employees, so then you better remove that outlier. Yeah, the CEO. Yeah. Reg?
Professor, I just want to ask you for the in case of the outliers, which will be the best method to?
Which is the better method?
Yeah.
Well,
or any other method?
Yeah, if the advantage of the high-low is if you know, okay, it's a very good linear relationship, right? Then you use 2 point. That's easier, right? Simplify your calculation, right? But if other than that, it's always better to use regression analysis. But the idea is it takes additional effort, the regression analysis, but not really. I think nowadays with computer, it's probably easier to use regression analysis. The computer did all the calculation for you, right? Instead of you figure out what's the high-low, you just click a button, add a trend line, and display the equation, and everything's there. Okay. Yeah. Okay. So the third limitation is the data point. Okay. The regression is more accurate when you have a large amount of data point. Okay. So when I prepared the slide just before the start of class, I was thinking, how can I find a lot of data points, right? So then I found this picture. Do you like it? So when you have more data points, right, your regression analysis will be more accurate, right? Okay, that's it for today. As you can see that we are finished earlier. Okay. This week is a happy week, right? We are not very heavy in terms of content, and we only have 1 lecture. Okay, so hopefully you can take advantage of this time, try to catch up with some of the work. The assignment will be available after the end of the lecture, 4:45. Okay. So if you don't have any question, class is dismissed. Okay, you have a good, well-deserved holiday. And for that too, gentlemen, again, I apologize for putting you on the spot. Okay.
Thank you.
Yeah. Okay. See you guys.
Thank
If
you.
you have any question, please stay. Okay.
Thank you. Thank you.
Thank you.
Bye. Okay, so Jimmy?
Yeah, I was wondering if there's a good time to ask about questions from the past homework assignment from the weekend.
Is that due already or not yet?
No, sorry, from last weekend, just because I was working through that long question that had 21 points. And
Is that, sorry, Jimmy, is that assignment 1 or assignment 2?
that was assignment 2.
Assignment 2 is already due, right? Is that due?
Yes, exactly. Yeah. So I was just wondering if is it better just to make an appointment with you for just some office hours, just to kind of go through some of those questions from the assignment? I think that we can still review.
Did you watch the video I posted? Did you watch that video?
I did, and I
Okay.
actually looked through the case too from class, from the video, just step by step in my notes. But one thing I had a trouble with was one of the numbers. I have to go get my notes. I don't have them on me, but